Yeah, so like Spru said, I'm an engineer at Cask. Did a master's in AI at Stanford, worked at Yahoo for a bit on recommendation system, box and search at box. And so I'll be talking about machine learning for the masses. I'll start off with a little story about this friend of mine. He's a engineering manager at a large social media company. And he likes to make these little videos, these little hacks, gadgets for his kids, and they upload them online. And he was telling me about this project he was trying to do where he wanted to make this piggy bank for his daughter, where you put in bills and keep track of how much is inside. And what he wanted to do is just create something super simple. You take a little picture of the bill coming in, see if it's a 1 or a 5 or a 10. And that way you can keep track of the counter. But as he was trying to do this, he was saying he just didn't know how. Right? He was checking out all these different AI libraries, and everything was too complicated for him. He has no background in this area. He doesn't know what's a tensor, what's a vector features, things like that, and so he wasn't able to do it. Right? And as we've seen machine learning get more and more used in different enterprises and talked about more and more, we've seen a little bit of the barrier to entry go down. So I'm going to be talking about some of my experiences here and talking about how we can push it down even further so that people like my friend can do what they're trying to do. So first off, just what is machine learning? I'm going to define it as we're just using existing data to make predictions. Okay? So we want to keep everything super simple, something that anyone, anywhere can understand. And generally how you do it, right? Usually you start with gathering some data, then you prepare it, you pre-process it, you clean it up a little bit, and then you run it through some library for training, and then you evaluate it, see how good it did. And usually at this point you'll see it didn't do as well as you might think. And you might go back to one of the previous steps. You might try different parameters for your model of trainer. You might see that your data is a little funny. You might want to filter things, you might want to change it a little bit. Or you might go and you might gather additional sources of data to see if you can get more types of signals. So it seems like fairly straightforward. When you actually do it, and you do it in production, things go very differently. And so I used to work at Yahoo. About 8 years ago, I worked on a team, and we would recommend news stories to people. So the front page, we would determine what stories get shown to different people, in what order. And I'll talk a little bit about what it looked like there, what I did, what our data scientists did. And so when we started, my expectations were I'll just make some of this data available to our researchers. What have people viewed on the home page, what have they clicked on. I'll wait for them to create a model. They'll give me their code, see how they did it. I'll change it a little bit, make sure it's production ready. It has like logging, has metrics, monitoring, stuff like that. And then we'll release, and then we'll be all happy. But what actually happened was I made it available, and then waited for the data scientist. Then made some more data available, waited again, and repeated this a bunch of times. Then by the time I got their model, it was 37 steps. All these steps, there's one that was written in Python, one in Perl, one that had command line stuff with sed and awk, and running through MapReduce streaming, running an MapReduce job, a whole bunch of stuff, right? And then it was up to us to make that ready to run in production. So basically, we had to completely rewrite stuff, understand exactly what was happening in each part. Then we release it, and then we measure it, and then the data scientist says it's not performing like it did in my lab environment. And so we just ended up reverting back to our most popular model. Right? We just show the most popular news stories. And so eventually, as we do this more and more, we get a little better, and we have actual machine learning on the site. But it's very dirty, right? Lots of not very nice things in this process. And similarly for the data scientists, right? Their expectation is I'll just get some data, I'll perform some cleanup, generate my features, I'll train, and I'll evaluate, and repeat until I'm happy with it, hand it off to engineering. We're all good. But what actually happens for them is they gather a bunch of data, they perform cleanup using a bunch of different tools, because there's not a whole bunch, there's not a single place where they can do everything they want. They realize the data is wrong, talk to the engineer, to see if they can get it fixed. They start generating their features and they realize, hey, actually, I need a bunch of different data. Talk to the person and realize, oh, that data was already there, but in a feed that I didn't know about, because I have no governance and I have no discoverability. So eventually, most of this, after a whole bunch of time, they train a good model, hand it off to the engineer. Engineer rewrites it, right? You release it, underperforms, and then they wonder if the engineer actually do it correctly. Likewise, I don't know what's wrong, right? So what went wrong there? There's a couple things, and it's basically that there's all this handoff happening, right? The engineer can't really use any of the stuff the data scientist did. The data scientist can't do his stuff in a way that engineering can use it. And they're using a whole bunch of different tools for preparing, for cleaning, for training. Right? There's not a single place. And so how we can solve this, right, is you have a unified environment for everything that is related to this whole process. And you make it easy for the engineers to do the machine learning types of work that the data scientists do. You make it data scientists easy to do to create a production-ready application. And so that way things are reusable, right? When the handoff happens, there's not much work that actually happens. And when you do this, you don't only make it easier for the engineer and the data scientist, you make it easy enough that anyone can really do it. And you lower the bar. So that's where we're trying to step in and provide a solution. So CDAP stands for the Cask Data Application Platform. And that's our core product here at Cask. And what we have at this is kind of like a high-level architecture. At the bottom, you have your cluster. It's running either on bare metal or it's running on a cloud. And then CDAP sits on top of that. And what it is it's a set of different services and a programming API that gives you a lot of different kind of platformy type of things that you want on top of your cluster anyway. So things like governance of your data, lineage and metadata, things like metrics and logging and alerts, scalability of your apps and things like that. So that's what the platform gives you, kind of all these underlying have-to-have type of things for production. And on top of that, we have different solutions, and that's shown on the top right, that solve the normal use cases that people have when they get started with their data. So things like ETL, creating pipelines for your data, things like CDC, change capture engine, things like rules engines. So these are things that come on top of the platform prepackaged that we deliver. And then now we're adding a little piece for machine learning. That will kind of build on all the other things that we have, things like data prep, things like pipelines. So with that, I'll just show a demo. Easiest just to see it. Increase this a little bit. Okay, so this is the UI for CDAP. And this is kind of the control center. So we're adding this little analytics tab. From here, I can create an experiment for my machine learning. So let's create an experiment. And I'm going to be using some data, some depressing data. Where is it? This is some real estate sales data I scraped off Julia about a year ago, so the prices are already much lower than they are now. But we're going to be trying to create a model here that will predict real estate prices. Okay. And this brings me to our prep view, and this is the exact same prep tool that people use to normally create pipelines and data. And so the experience here looks exactly like it does in the other parts of the platform. So I'm going to first parse it, tags. And here I get dynamic feedback of changing my data. So I see here I have a price. This isn't really a string, so it looks like integers. So I can change the type here. City, zip, type, beds. This is also integer. Bats, 2.5 here, so I'm going to have fractions. So I'll change it to a double. Size in square feet. Let me change this also to here. Lot size. Try to change it to here. Oh, and we see here there's one value for 0.25, so let me change it to a double. Number of stories, build year. I can do more complicated things, where I can set a default value if it's empty. So let me just say 1970. It's missing. Change this. And so I can do a bunch of different things. I can filter. I can write custom little expressions. But for now, this looks fine. Let me try to create a model from it. And here we select what we're trying to predict, and that's price. We'll create a name for this experiment. We'll call it RE for real estate predictions. Right? And we'll create a first model. So let's call it M1. Okay, here, now we go and we split our data. So this isn't happening in the UI or anything, there's a backend for it that we're calling. It's actually splitting the data, calculating stats for it, saving the splits. It should take just a few more seconds. All right, first thing I notice is price looks kind of funny, this histogram, right? Everything's in here. But I have a median of 3,000 and a max of 30 million. So this is something I'll keep in mind. It's kind of funny. Maybe I want to filter things out. I can look at different things like bedrooms, right? So the blue is the percentage of the test data that falls 2 to 3 bedrooms. And so I'm expecting these to be about the same. It means I have a pretty good data split. And if I look at like the sizes, I see something similar, right? There's a lot of, the min is much lower than where most of the data is. The max is much higher than most of the data. I can see I have 24 unique zip codes, 10 different cities, things like that. Okay. Let's just say I'm happy with this. I'll move on to the next point for now. And here, because we have a double for our prediction, we're selecting different regression types of models. And I don't actually know what any of these is, so I'm just going to pick the first one. I can configure stuff if I know what these are. Let's say I don't know what they are. So I'll just choose the default. I'll hit train. That brings me here to the list view for my experiment. Currently I have one model, and its status is training. I can see the preparation directives that I'm using to clean it. And look, it's done training. So if I refresh it, I'll get some stats like RMSE, which is root mean squared error. Mean average error is just what's the absolute error on average. And if I want, I can look at this data set for the predictions and run SQL queries to see samples of the data. So I can do something like anything you want from SQL. So like absolute value of prediction minus price, error, show me error. I can do things like what's the order by error something. This one has the order, so it'll take a little longer. I can see, okay, this first one, it's $3.7 million off. That's quite a bit. I can see maybe certain cities are more susceptible to errors. So let me see. Let me try to filter where the error is greater than, let's say, 200,000. Right? So that gives me that, and then let me group by city. So let's do city count star. From this, where that's grouped by city. And then here I can see, okay, I have 19 really bad ones from Cupertino, 11 from East Palo, Mountain View. I can download the full results, take a look, and maybe do some different things, right? But one thing I remember is that price was kind of funny, right? No price here, no house here is going to sell for $3,000. So let's try to do something a little different. Let's filter these things out. So I'll remove rows if price is less than 1 million. And I'll also remove rows if the price is, let's say, greater than 5 million. And let's see how that changes our results. So again, I split. I can see here, okay, it looks much more normal. I'll do this thing again, train it, watch it go. If something goes wrong, I have logs here. Let's train, let's refresh. You can see here the error is less, right? And you can imagine this will go on and on. I can create another model, change the parameters, see that how that affects things, use a different type of algorithm, see how that affects things, and iterate, iterate, iterate. And once I'm happy with it, so let's say I'm happy with this, I'll copy this model ID. Now let's say I want to use this model to actually predict some data. I can go create a pipeline. And so we'll start in our prep view again with this same file. Right, we'll create a pipeline from it. And we'll add this little plugin here, which is a predictor. And so here, we configure this. The experiment we call it was RE, the model I have from there. And we'll add a prediction field. This will be the predicted price for the house, or the property. And we'll write it to some sync. We'll just do some avro sync. Right. Predicted prices.
The type has changed now. The prediction type.
Oh, it's a string. Let's change that. It's a little bit double. And propagate it. Double check its script here. Double. Okay. We can deploy it. And this model and this pipeline is exactly the same thing. So the thing that the data scientist uses is exactly the same thing that you would run in production with metrics and logging and lifecycle and all the platform types of things you get, lineage, metadata. So if we run this, we're running it, I can schedule it to run on a periodic interval. If I get these feeds coming in regularly. So running, we get logs here. Take too long, okay. You can see metrics here, the number of records coming in and out. And it's now succeeded. So I can go back to my control center. Let's take a look at some of these pricing predictions. Okay, let's choose ones where the price is greater than $1 million. Okay, and here you can see this one actually sold for $1,001,000. Prediction is $1,167,000, and other things like that. And so now I've just created a model, and I've created a pipeline that uses that to make predictions. I can run periodically, and I've gone from just messing around on my laptop to something I can use in production in however long it took, 10 minutes, 15 minutes. And so we're also making it so that the algorithms and different things you can use for the more advanced users are pluggable. So you can put in your TensorFlow, you can put in your H2O, whatever, write your own thing. But for most cases, you probably start out, you just want something that's good enough, right? And so we'll include a bunch of stuff that's probably good enough to get you up and running, to get you looking at things, and then you can really, when you really want to fine tune it, you can fine tune it. So yeah, that's the demo. I think that's it for that's all I have. Yeah. Questions? Any questions? Yes.
Okay. That was very impressive. You ensure your the disconnect between engineering and ops, right? So I mean the data scientists who trying to talk. My experience dealing with models is that the more data scientists, they tend to work in R. In both commercial and others. Bank documents and file. So, because you mentioned Yahoo, I'm trying to add the others, because Yahoo has its own stack, right? So Microsoft and others, they have developed tools that ties to R, more the developer platform. So how do you address that? Meaning that I'm curious. I mean, I think there is a mind share, trying to grab mind share. I mean, you're doing this, which is great. I now know where I can help people that, well, try this. If you like R, you can like Python, try this, right? So that's great. But again, what I'm trying to propose maybe something you know that I don't is that most graduates and undergrads, they either are Octave or not, right? And from different disciplines, and then Python. So how do you, so they're not like introduced to this platform as a first experience. Of course, get familiar with it. So is there something that you want to lead them to it beyond the SQL, like the microstrategy and the Informatica model?
Yeah, so about R. So I've used R and
so it's not specific about our language, I'm more just
right.
How do you get something that is like half a dozen and to a dozen, first order, second order.
Yeah.
How do you get them to get to your platform?
Yeah. So I can tell you a little bit about my experience with R in graduate school. Right? So I did something very similar to this, a decision tree in R for real estate. That was one of our projects. And there you started with data that was in the exact format that you need for R. And I think for most data scientists, most of their time is spent getting data, preparing it, cleaning it up. Right? A little bit is spent in actually training it. And so the first answer is that we still think we add a lot of value in that piece, right? Preparing your data, being able to do things with it, having it connect to all your different applications, making it production ready, that piece. In terms of R, we've and different types of like systems that people use to train their models that don't fit in here, right? So part of the design of the system here is to try to make it pluggable so that you can use these things. R specifically is a little difficult to fit into that just because of the way it runs. The platform here kind of assumes you're on a distributed cluster environment. And so we've done some experiments with R running it in this type of distributed way, but it doesn't fit in too well there. And so to that, I don't know, we'd have to look more, right? But the idea here is that you have a layer on top in which you can put in different underlying pieces, different engines, like TensorFlow, like Spark, like Flink, different things that have machine learning capabilities. And as we figure out how we can plug them in, you'll just get them for free along with all the other things. So that's kind of the thinking around that. If that makes sense. Other questions? Yep.
So does it change what the data engineers do then when they this kind of model?
Yeah, so it kind of, right? So it's like you're using a different tool for prepping your data, examining it, but everything is in one place, right? You're not using like Hive to run SQL queries to look at your data and then running it through like Trifacta for doing data prep and then running some Spark stuff, some MapReduce, like a bunch of different things, right? Here it's all in one place, and the transition to move it to production is like painless. And so the idea is that your data scientist is no longer, the stuff that they do can just be reused immediately. They're not just writing crazy scripts off on their own. And so it probably changes a little bit what they do. Hopefully it makes their life easier. I think it does. Other questions?
Okay, one more. Just a follow-up. Then you mentioned crazy script, so that's what's touching off on this context.
Okay.
So how do you do version control on the versioning on your model?
Yeah. So I didn't show that piece because
cool.
it's not in the
follow-up. Yeah.
right, because it's not in the UI yet. But basically, we have a notion of you publish certain models, right? So once you're happy with it, then you publish it, and only then can it be used. In terms of controlling versions, so right now you just create different models, right? And so you'd have to create a different model with a different name. We're thinking about how you would, do something where you create a model, then you want to periodically update it. So how would that look like? That part's not fleshed out yet. But also the part I haven't showed is being able to tag these models with different things. So you can tag it like this is V1, this is real estate, and then being able to organize and search for things like that. And then part of it is also in your apps on the platform, you get lineage information. So you can always see, for this data set that was using this model, where I can track where the data came from. So I can do kind of backwards looking up from that. But in terms of full-blown version control, that's not in our future. This isn't actually released yet, so I just showed kind of an alpha version. It's clearly something you would want in production.
Well, I mean, if you go for big customer, yeah. I mean, you would want Verizon to use it.
Yeah. All right. I'll hand it off to Kevin.
Thanks a lot.